Okay, so let's take a look at the first problem. The t-value for the 99% confidence interval estimation based upon the sample size of 10 is, so basically the problem asks you to find the t-value, right? When the confidence interval estimation, confidence coefficient is 99%, right? Then and also when the sample size is 10. So what is the t-value, right? Okay. We're going to use Excel spreadsheet, but before we're using the Excel spreadsheet, I would like to show you, how to find the z-value first, right? Using the Excel spreadsheet. This is something that we learned. This is, by the way, this is review. Let's say we have a z distribution, right? So this is not a t-distribution. Let's say we have a z, or like we have a normal distribution, not the t-distribution, right? And as you can see, the area to your left is, let's say, 0.95, like a 95%, like 0.095, that's a probability. And so in that case, right, if you want to find the z-value, right, so assuming that this is a normal curve, right, assuming that this is normal curve, normal distribution, right, and if you find the z-value here, right, and the functions that you should use is what? The function that you should use is to find that this critical value here. Norm. Oops, there is a norm, right? Norm dot. You have to use a norm dot. S is used for the z value, right? Dot inverse, and then you simply put that probability. In this case, in this example, is 0.95, right? And then you can find the z-value, right? But if there is a mean and standard deviation is given, let's say the professor grade with a normal curve, right? And assign the grade of A for the top 5%, right? So if you want to get an A in his class, you have to be in this top 5%. That means the probability to the left is basically 0.95, right? So the mean is given, and then this standard deviation is given. In such a case, if you want to find the x, not the z, right? And if you find the actual x value, right? Then you can use norm dot inverse. Note that s is you don't use s, right? Because you're not really finding the z value. You're actually finding the actual value x, right? X. In that case, you put the probability p, the red, right? Same thing is a cumulative probability. And then 79 is a mean, is given, and the standard deviation, right? And you can find the x, okay? But in this case, our problem is a t-distribution, right? For the t-distributions, you can use a function called t.inverse, okay? That 2t, so 2t means for the two-tail. And as you can see, if this is a t-distribution, right? Then, if this is your t-distribution, and you use these functions to find this t-value here. T-value, so this is called t-critical, t-value here. And then the equation is you have to use the p. So p is a probability, right? And then df is a degree of freedom, which is n minus 1. This n is a sample size, minus 1, you get the degree of freedom, right? And this probability p is a red, right? The red p is, this p is the area, right? Can you see the area right there? It's the area underneath these t-distributions, which is a probability, right? So the example is, let's just use our example given in the assignment, right? Let's see, where is the, okay. Okay, so example is a 99% confidence interval, right? The 99% confidence interval. So I'm going to use that as an example, right? So this is an example. And you know that this is a t-distributions, right? And since this confidence coefficient is 99%, and this means it's 0.999, sorry, and the level of significance, which is alpha, we know that it's 1 minus cc, right? Which is 1 minus 0.99 and is equal to 0.01, right? Okay. So that means when the alpha is a 0.0101, right, in the two-tail test, is you know that this is two-tail, and then you know that this is what the cc is 0.99. So we know that this area is what? Is 0.99. That's a probability, right? And then the red area here, right there, is 0.005, and this is what? 0.005, because it's what? Alpha divided by 2, which is 0.005. But anyway, this area together, right? This area, on your left side and the right side, if you add this together, you have 0.05, right? I mean 0.01, right? So to find this t value, right? To find this t value or t critical is what? You can use the functions. You can use these functions, right? Which is t dot inverse dot 2t, right? And the probability is, adding this 2, right? Which is 0.01, which is actually alpha, if you think about it, right? And degree of freedom is 9, because what? N minus 1, right? So n is a 10, so degree of freedom is 9. Okay, so that's how you should use this code. Let's see if there's anything that I can use. Okay, so let me just use this. Let's see. Okay, so if you want to use Excel spreadsheet, right? So basically it's equal to what? T dot inverse dot 2t. Okay, and then is a 0.01, right? And then 9, right? So that's the oops, I put the 2 t's. Sorry for the typo. Should be t dot inverse at 2t, right? This is how you can find the t value, right? Okay. Okay, so another thing is there's another interesting function that you should know. I mean, you don't have to really know this to solve the problem, but maybe this could be useful later on. And another functions is what? T dot inverse functions. T dot inverse is also used for the t distribution, but there's a big difference between the T dot inverse at 2t and T dot inverse. As you can see, if you want to use the T dot inverse functions, right? If you want to use these functions, you know that for this first argument p, is really this p represent the area, right, to your left. Okay, so this blue area, right? If this blue area is, let's say, 0.1, or like, which is 10%, then you have to put a 0.1, right? And if this p is, for example, if this p is, let's say, is 1%, right? Meaning that 0.01, then you have to use a t dot inverse, and then 0.01, right? Which is 1%, right? And then let's say degree of freedom is, that it's, let's say n is a 10, then your degree of freedom is 9, right? And it's very likely that you will get some negative value. So that's your t value, t critical. So you know that this is 0. So you will get some negative value, negative t value actually. Okay, so this is like another interesting function that you should know, t dot inverse, right? And a lot of people are confused with these two functions. Yes, I think it could be really confusing because the first functions, right? So for the P, for the probability, they use this red area, right? That's the P. And for the second functions, for the P is really like blue area, right? And that's the return value. And for this, the first one, the return value is actually the right one. So you always get the positive value, positive return value from this function 1. And function 2 is really depends on the area, right? So it could be the negative or it could be the positive, right? It depends on the area, the blue area, right? Okay, so I'm done with the first problem. I think I covered more than what you need to know to solve the problem, but I think it's important for you to know everything that I discussed so far. Okay, so okay, so now let's take a look at the second problem. So first read the second problem. Statistics teacher studied the class one day by drawing the names of 10 students out of a hat and then asked them to do as many push-ups as they could. So there are like 10 randomly selected standard students. Average is about 15 pushes up per person with a standard deviation of 9 push-ups. Okay, good. Okay. And suppose that distribution of the population of the number of pushes up that can be done is approximately normal, right? Okay, so the 95% confidence interval for the mean number, the push-up that can be done is, so this problem basically asks you to find the confidence interval, right? Okay, so let's talk about this problem number 2. Okay, so that we learned about the confidence interval, right? So this is like previous lecture. So confidence interval is basically point estimate plus minus t critical multiplied by the standard error, right? Standard error is s divided by root n. Okay, so basically let's look at the problem number 2. The problem number 2 said there's a populations, and we know that this population is followed the push-ups, right? So there's there's students, this is like populations, and then you have sample, right? And then let's say how many students? 10 randomly selected students. So there are 10 students, right? So sample size is 10. And then you calculate the average push-up, right? And then this the sample mean is how many push-up? They said 15 push-up per person. And also from this sample, they get standard deviation of the 9 push-up. So standard deviation of this sample is 9 push-up. Okay. So now from this, we need to basically they ask you to construct the 95% confidence interval, right? To estimate the true population mean, right? Okay. To estimate the true population mean. Okay. So as you show in my let's say in previous lecture, the confidence interval is point estimate plus minus t, right? So let's just go back. So the confidence interval, right, is basically the point estimate, right? And then plus minus the marginal error, right? And so we try to calculate the confidence interval. And the point estimate is basically, you can use a sample mean, right? So we know the sample mean is given. And for the marginal error, right, is basically plus minus. You need to multiply the t critical value. This is like from the t distribution. So the c, okay, oh, by the way, the 95% confidence interval, right? So the CC, the confidence coefficient is 99%. Oh, 95%, sorry. If you look at the problem, it's 95. Okay, so 95%. So that means what? It's 0.95, right? From this, we can calculate the level of significance, right? Which is alpha is 1 minus CC, right? Which is 1 minus 0.95, and which is 0.05. Okay, so that's alpha, right? So using this formula is alpha divided by 2, okay, because we are really need to consider two tails, right? So always for the level of, for the CI, the confidence interval is always the two-tail case. So you know that this is 95%, which is 0.95, and we know that this is 0.025, right? And then this one is 0.025, which is alpha divided by 2, right? So that's why we put alpha divided by 2. And it's multiplied by the standard error, okay? And in this case, the standard error is, by the way, alpha divided by 2 is 0.025. So now it's 0.025. And multiplied by standard error is, since we don't know the population standard deviations, sample standard deviation are divided by root n. So that's a formula, right? Okay. So there's a couple of ways. So now the full formula is what? So since point estimate is x bar, so basically x bar, so your confidence interval is x bar minus t 0.025 multiplied by s divided by n, comma. So this is what? This is lower bound, right? And upper bound is x bar plus this time t 0.025 multiplied by s divided by n, right? So that's a formula. So this is the upper limits. So that's your confidence interval, right? Okay. Okay, so to find this problem, so we know that it's x bar, right? So everything is given, right? Pretty much except the t value. So you know that this x bar is the 15, right? So we know that this is 15. And s is also given, which is 9. So we know that this is 9. And n is given, right? Which is 10. So only thing that we need to find out is, by the way, this is multiplications. Okay. Only thing that you need to find out is what? This t value. Okay. And then you can use Excel spreadsheet to find this t value, right? T 0.025, right? Okay, so to use the to find the t value, we can use the this functions, right? T dot inverse dot 2t, right? So so basically we can use this functions t dot inverse dot 2t, right? Okay, so so to find the t value, right? So we know that this area, right? So use to find this t value here, right? To find the t value, basically t what? To be precise, this one can be 2.025, right? We can use which functions? The t dot inverse dot 2t, right? And then the area, the red area, right? The red area is basically what? It's 0.05, which is alpha, right? So 0.05, and the degree of freedom is 10, right? I mean, sorry, this n is 10, so degree of freedom is 9, right? So that's something that we have to use to find this t value. And once we find the t value, then we can compute the marginal error, right? Okay, so let's use Excel spreadsheet, right? Let's see. Okay. Oops. Okay. So I want to, oops. Okay, so I want to find the t value. So let's say, you know what? Let me just write down everything. Let's say the point. Let's say point estimate, right? point estimate is equal to what? Point estimate is equal to 15, right? Which is x bar. And then what the standard deviation, sample standard deviation is 9 push-up. So you can see the standard deviation is 9, right? 9 push-up, right? Okay. And then what? And n is 10, sample size is 10, and then degree of freedom is basically what? It's n minus 1, right? Which is this minus 1, which is 9, right? Okay. And then what? The t value, right? T value is, I'm going to use, actually before we use t value, I think it's better to what? The confidence coefficient is, we know that it is equal to what? 0.95, right? And then the level of significance, which is alpha, right? This is equal to 1 minus cc, right? Which is 0.05. Okay. So now, given this t value, right? T value is equal to what? T dot inverse dot 2t, right? And then you have to use the alpha, which is this guy, right? So that's a probability, and comma, and the degree of freedom, which is 9, right? So that's a degree of freedom. Okay. Okay, so that's my t value. Now I can calculate the marginal error, right? ME. My marginal error is t times s divided by root n, right? So basically it's equal this t value multiplied by a sampling standard deviation, which is this guy, right? And divided by square root of n, right? Which is, where's n? Okay, so there's n, right? Okay, so that's my marginal error, right? Okay, so now I want to find this lower limits, right? So lower limits is, what is the lower limits? I like to find this lower limits, which is whole thing. So this is going to be my lower limits, which is x bar, which is point estimate, right? So it's equal to point estimate minus, right? I have to put a minus, right? So the minus, and then my marginal error, right? So x minus my marginal error. What is my marginal error? Is this guy, right? Okay. So that's my marginal error. So that's like my lower limits, right? That's how can you find the low limits. I think now you can find the upper limits, right? So that's probably problem number 2, right? That's the solution for the problem number 2, and then find out, okay? And upper limits as well. By the way, this is going to be on the final exam, right? So you have to really know how to do this, right? So practice and practice, okay? Thank you. Okay, so let's look at the problem number 3, right? Looks like the problem number 3 is construct 95% confidence interval for the mean savings for the televisit to the doctors as opposed on an office visit. So here's the data, right? So let's just read the problem. Health insurance are beginning to offer the telemedicine service online. They replace the common office visit. So this is the data, right? WellPoint provide a video service that allows subscribers to connect with the physician online and receive the prescribed treatments, right? The WellPoint claims that the use of its live health online service saved a significant amount of money on a typical visit. Data shown below, actually those are dollars, for the sample of 20 online doctor visit are consistent with the savings per visit reported by WellPoint. Okay, so basically this is a sample, right? And then they ask you to find the 95% confidence interval, right? So what you have to do is first go to the data and download the data, right? Okay, so download the data and open. Okay, so enable editing. Okay, so for this problem, I think I showed you how to solve this problem, right, in the class. And for you, okay, so this problem I show you how to solve, right? How to calculate the confidence interval using the Excel spreadsheet. So if you go to our class, the YouTube site, right? If you look at the BA Chapter 6 confidence interval part 3, or I think part 2 or part 3, I think the part 3, right? Is talking about how to use Excel spreadsheet to find the confidence interval, right? When the data is given like this. So I want you to watch this video tutorial. If you are not remember what I discussed in the class, I want you to watch this video tutorial. I think it's the part 3, especially. I think part 3 talks about the how to use Excel spreadsheet, and part 1 and part 2, of course, talk about the estimating the confidence the calculate the confidence interval, right, for the population mean. And then part 3, that's talk about the how to calculate the confidence interval with the Excel spreadsheet when the data is provided. Okay, so I want you to look at this part 3, confidence interval part 3, and part 4 and part 5 is talking about the proportion case, right? Confidence interval for population proportions. Okay, so that's problem number 3. Okay, so now let's look at the problem number 4. And this problem is interval estimation of population proportions. So one of the questions on a survey of 1,000 adults, so basically the sample size is 1,000, and asks if today's children will be better off than their parents. Representative data are shown in the file name Child Outlook. The response of the yes indicates that adult survey they think that today's children will be better off than their parents, right? And the response of no indicates that adult survey did not think their children will be better off. So basically the response is yes or no. And response of not sure, okay, there's one more response. So basically yes, no, or the not sure, right, was given by 23% of the adults surveyed. So click on the data file logo to reference data. Okay, so let's just first download this data. Okay, and then please download. Okay, so and then enable editing. Okay, so let's take a look at this data, right? It has actually one column only, and then not sure, and then yes, no, right? So how many of them? I think it's pretty, okay, so 1,001. So 1,000, right? So n is 1,000 because the first column is just header. So 1,001 means there's a sample size is what? Sample size is 1,000. Okay. So let me write it here. So I'll say, let me just make it this a little bit larger. Okay. So we know the sample size, right? The sample size n is what? Is equal to 1,000. Okay, so that's what we know. And then response of the interest is yes, right? So response of interest, right, is a yes. And then let's see. So the count, right? The count for response. So we need to count how many of them really say yes, right? Is, let's see. This is equal, right? And then for this, we need to use what? We need to use, I think it's functions that called hold on. Oops. Okay, so we have to use what? Okay. So we need to count the number of yeses, basically, right? And so we're gonna use the function called COUNTIF, right? Okay. So for the count of responses, we're gonna use the count, right? And if, and this one starting from A2, right? Oops. Starting from A2 and then all the way to 8001, right? So A1001. Okay, so that's the last one, right? And then what is the so we need to count how many yeses, right? So there's a comma and that's the response of interest. So that's the yes. Okay, so that's yes. So how many yeses basically? Okay, so 240. Okay, among 1,000, 240 people said yes, right? Okay. Okay, and then the sample proportion, right? So the sample proportion, which is a p bar, sample proportions, which is the 240 divided by 1,000, right? So that's like so that's a percentage of people saying yes. So it's equal, and this divided by the sample size n, so 0.24. So that means 24% basically people said yes, right? Out of 1,000. I mean, out of 100%, right? So 24%. Okay. So before we go to move further, right? Let's just look at the formula, right? For the confidence interval. Okay. So we know that this is what? This is the proportional case, right? And we covered this. Let's say, okay. So this is like this is the population proportion, right? This is, by the way, my lecture note. And the same thing, we have point estimate, plus, minus, and marginal error, right? And then the most important, right? Oh, see, the most important formula is what? This one. P bar plus minus Z critical, right? Multiplied by root P bar 1 minus P bar root n. Okay, so that's the most important formula, right? For the confidence interval, right? So okay, so for the population proportional case, let's just review the confidence interval. Oops. So the confidence interval, right? CI is what is the formula? Point estimate plus minus marginal error, right? And then this is plus minus Z critical. So this is a Z value. For the proportionals, is no longer T distribution. So it's alpha divided by 2 multiplied by, right? And standard error, right? Actually, the estimate of standard error, because we don't know the true populations. Actually, the standard error is the right formula for is what? For the standard error, the formula is what is it? Root n, right? P 1 minus P, right? But we don't know the true populations. Okay, so by the way, this is the same thing. So we have a populations, and from the populations, we have a sample, right? And there are samples. And then from the samples, we can compute the sample proportions, right? And since we don't know the population proportion P, we are going to use P bar. So basically, we need to use an estimate of standard error, right? So this is plus minus Z and alpha divided by 2 multiplied by the standard error formula becomes, now is N, P bar, and then 1 minus p bar, right? So this p bar is from the sample, right? So this is a sample. Okay. So so by the way, this is a marginal error, right? Okay, so this is the marginal error. Okay. So that's the formula, right? That's the formula, right? So the lower limit is, by the way, the point estimate is, of course, you can get this p bar, right? The sample proportion is your point estimate. So this is p bar, right? So the lower limit is p bar minus, right? Minus the marginal error, which is z critical multiplied by root value, right? Which is n p bar 1 minus p bar, right? So that's a lower limit, and upper limit is p bar plus the marginal error, right? Okay. So that's the upper limits. So let's just try to first find the lower limits, right? Using the Excel spreadsheet. Okay. Okay. So hold on. Okay. So we know that, by the way, the problem said the confidence. So the CC, right? In the problem said the CC is 95%, right? So this is like a 95% confidence interval. So that means alpha, the level of significance, is 1 minus CC. So this is 0.95. And this is what? This is what? 0.05, right? Okay. And so basically to calculate the marginal error, right? So we need to first find the Z critical, right? When the alpha is 0.05. Okay. So we learned this, right? Actually, we don't have to calculate because I asked you to kind of memorize this number, right? So if you look at the previous lecture note, I said, where is it? Oh, here. Is this the right? No. I think I put it somewhere. Let's see. Oh, here. Oh, okay. So in my previous lecture, right? Okay. So for the Z distribution, right? The normal distributions, when the confidence is 95%, right? And let's see. Oh, here. When it's a 95%, this value, right? Where is it? Where is it? Okay, so actually it's right there. So for the normal distribution, right? The confidence is interval. Confidence coefficient is 95%. The Z value is what? This Z value, right? The Z value is 1.9599, right? And then when confidence level is 90%, your Z value is 1.6448, roughly 1.65. And then for the 99%, my Z critical, right? The Z critical value is 2.575, roughly 2.58, right? So you can use this value to basically right. So basically you can use that value, right? For the 95%, like 90%, 99%, it's really well-known values, right? So you can use that value, but I'm gonna just calculate the Z value anyway. Okay, so using Excel spreadsheet. Okay, so this is given, right? So what we need to find out is actually this Z value, right? So Z alpha divided by 2, which is Z 0.05, right? 0.05 divided by 2, which is because for the confidence level, we're always talking about the two-tailed case. Okay, and then this is what? Z 0.02, 0.25. Okay? Okay, so that's the value that we have to find. So let's just use the Excel spreadsheet. Although we know this value, right? Okay. Okay, so so let's just move on. The coefficient, I mean the confidence coefficient is known as a CC, right? What is a CC? Let's just make it a little bit big. Okay. So the confidence interval it's what? Given, right? Given by problem, which is 95%. So this is given by problem. And then the level of significance, which is alpha. The level of significance, which is known as alpha, right? It's It's 0.05, right? Okay. And now we can find the z value, right? And the z value is what is the z value, we can use the function called normal.s.inverse functions, okay, which is equal to that norm. Now s, whenever you use s means that you need to find the z value, right? So s means find the z value. S dot inverse dot actually 1 minus, okay, so 1 minus. Okay, so to find the z value, right, you can use you can use a norm dot in s dot s means z value, right? So you can use the norm dot s dot inverse, basically 1 minus, equation is the alpha divided by 2. Where's alpha? Alpha is the level of significance, right? So this divided by 2, right? And then that is your z value, which is 1.959, which is close to 1.96, right? So that's the exact z value. By the way, for the z value, right? So let's talk, I already covered this norm.inverse functions, right? Remember this example. To find the z value, I use a norm.s.inverse. And then for the argument, right, you have to put the cumulative probability, okay? So let's just, hold on. So, okay, so now, okay, so let's just talk a little bit more about this norm functions, right? So remember in my previous lecture, right? So let's say this is a z value, and then you know that this is 0. So find the z value, right? The z value here, we use norm, right? And s is for the z value dot inverse, right? So if you look at the previous example, the norm dot s, right? So it's okay. So this one, right? So z value is norm dot s dot inverse, and then a cumulative probability, right? So you know that this is red part, right? Red area. So you have to put the for the first argument, right? You have to put the area of this red, the red area, right? Okay, so here, if you look at the problem, right? If you look at the problem, it says 95 confidence level, right? So which is 0.95. And then for the alpha is 0.05, right? So in this case, this is a calculated confidence interval. So we always need to think about consider two-tailed case. And this area, right? Okay, I should have used the blue, not the red. Oops. Okay. So, you know, this area is what? This area is the 0.95, right? And for this norm, for the norm S dot inverse functions, right? You have to put the probability, the cumulative probability up to this area, right? So basically, like, you know, the area all the way up to this point. So basically, I'm going to use the green, right? So first this argument, right? And then you have to put the probability P here, right? And this probability P is including everything. Okay, so that's the cumulative probability you have to put in here. Okay, so we know that this is a 95%, the middle value is 95%, right? So we know that this is 0.95, right? And then this one, right? This one is alpha divided by 2, right? So this one is alpha divided by 2, right? Which is, in our case, is what? 0.025, right? So actually the number that you have to put here is what? 0.95 plus 0.025. Okay, that's the value you have to put to compute this z critical value, right? This one. So basically that's the value, right? So basically, so this is a z critical, right? Okay, so that's how you can use a normal S dot inverse, right? However, you know, you can use basically the same thing, exactly same thing, right? But if you want to use a formula, right, for the calculating this z star, right? So by the way, this is a problem to find the confidence interval for the population proportion, right? Okay, in that case, there's another. I mean, that's the idea, right? So you have to put the probability, and so basically what? So norm dot S dot inverse, and then if you add this up, you're gonna be 0.9 what? So basically 0.95 plus 0.025, right? So if you add this up, 0.975, right? 0.975. Okay, so then you can find the this z value right there. Okay. However, I mean, if this is like too much, I mean, there's another formula you can use. Norm, basically same thing, S dot inverse, right? And if you look at my PowerPoint, I mean the Excel spreadsheet, I used 1 minus alpha divided by 2, right? So you can basically use 1 minus, right? The basically what? The alpha divided by 2, you know, which is exactly the same thing. So that means what? Norm dot S dot inverse, right? You know that it's alpha is, in this case, is what? 0.05, right? So which is 1 minus 0.025, and this is equal to what? 0.975, right? Which is the same as this. So if you think about it, what it really does is the 1, right? 1 means all the area underneath this graph, this distribution, and minus just this part, right? So you know that this part is what? Alpha divided by 2, right? So 1 minus this, let's say this orange part, right? Basically that's what it really stands for, this orange, right? Then basically the whole thing, this really represent the green area, right? So you can use like, I mean, they're conceptually the same thing, right? So basically, that's the idea. So you can use 1 minus this orange area, right? Oops. this orange area, right? 1 minus this orange area, right? Then you can get the green area, right? So that's like a 0.975, and that's what I used, right, in my Excel spreadsheet, okay? 1 minus D8 divided by 2. So you can find the Z value. Okay, now, once you have a Z value, we can compute the standard error, right? Standard error, so SE. S is, which is what? Okay. Okay, so if you look at this formula, the SE, the standard error is what? The standard error is basically this guy. That's a standard error, right? Okay. So your standard error is basically what? The standard error is, let's see, the square root, right? So it's equal to square root. And then that's a square root, right? Square root is P bar, which is the sample proportion, right? So that's a P bar. P bar multiplied by 1 minus P bar, which is the D5, right? And then what? Divided by N, which is the sample size, right? And that's a square root, right? Oops, I think, let's say, no. Okay. Okay, you know what? Let's see. The square root D5 multiplied by 1 minus, okay, divided by 2. Oh, I think I put extra parenthesis. Okay, that's a square root, right? Okay, so that's the value. Let me just... Okay, so that's the value. That's a standard error. Now, once we have a standard error, I can calculate the marginal error, right? Which is ME. And you know the marginal error is basically what? The marginal error is this part. That's the marginal error. So basically, Z critical multiplied by this standard error, right? So the marginal error is the Z is equal, right? Z value multiplied by standard error, right? Okay, so that's my marginal error, right? Now you can easily find the confidence interval, right? Because now you have a what? Now you have what? The marginal error, right? So the lower limits is P bar minus marginal error, okay? And the point estimate minus, right? So we know that it's, what is a point estimate? So the point estimate is basically same as sample proportion, right? Okay? And then minus what? Marginal error, right? So I think, oops, sorry. So that's a point estimate, right? D5. And then the lower limits, right? Lower limits is basically the point estimate, oops, equal to what? The point estimate minus the marginal error, right? So I think you can find the lower limits, and therefore also you can find the upper limits, okay? So that's the, okay, so I'm going to move to the next problem. Okay, so now let's move to the next problem, number 5. This problem is exactly like the problem number 4, right? So basically, the sample survey shows that 90% of the respondents said that internet has been a good thing, right? And basically develop a 95% confidence interval, okay? And then what is given is a sample size, right? And 95, then sample proportions, and 95% confidence interval, right? And if you look at the part B, the only difference is I think it's the sample proportions. previously sample proportion is 90%, now it's 67%, and etc. Okay, so now let's take a look at the problem number A, and I'm gonna spend like a couple of minutes, and because it's very almost, I mean, it's exactly the same problem. Okay, the previous problems you need to calculate the sample proportion from the data, right? But this problem sample proportion is given, right? So it's even much easier. Okay, now you need to conduct the confidence interval, right? So this is problem number 5. So what is given is the n, which is 1057, the sample size. And then to compute the confidence interval, you know that the equation is p bar plus minus. This is, by the way, this is point estimate, right? And then marginal error is z multiplied by n, the p bar 1 minus p bar, right? So we know the sample proportion is also given, right? They said 90%, which is 0.9, right? And then what is also given is confidence coefficient, right? CC. They say 95% confidence. So that means 0.95. And from this, we know that alpha is 1 minus CC, and which is 0.05. Okay? So I think you can find this confidence interval, right? So this is exactly the same as the previous problem, right? Okay, so first find the z value, then find the standard error, then find the marginal error, right? And then you can find the point estimate is given, right? And then you can compute the lower limits, and then you can compute the upper limits, right? Okay, so that's it for the problem number 5. Okay, thank you.